to the SpaceClaim tutorial on beam extraction. Today, we're going to learn how to extract beam elements from the cylindrical bodies as shown in the structure. We're also going to learn how to take the mid-surface edges from the panels and extend them to form connections to those beam elements. To get started, we're going to want to separate the beams from the panels. One way of doing that in SpaceClaim is by creating new components in the structure tree and reorganizing and putting different parts into the beams component and other parts into the panels component. But most of the time, what we're receiving and bringing into SpaceClaim is an assembly that was designed from a different application. And there already is a naming convention in place for the parts, as well as even a hierarchy for the sub-assemblies that are brought in with this assembly. So in this example, we probably don't want to edit anything in the structure tree. So the alternate way to organize is by using layers. So let's go ahead and click on the Layers tab. By default, every design has at least one layer. What we're going to want to do is create a new layer to place all the bodies we want to extract into that layer. Let's start by right-clicking in the white box of the Layers tab and click New. We have layer 1 created, and notice that it's bold, which means it's the active layer. And any new geometry that gets created from this point on automatically goes on the active layer. Let's go to the Selection tab, and let's make sure Search All Bodies is checked, and let's zoom into the left side of the assembly. Next, let's place our cursor over the cylinder and roll our mouse wheel forward once until the inside face is highlighted in yellow, and then let's click one time on the left mouse button to select the face. When we do that, we now have a list of options from our selection filter that we can choose from. Let's go ahead and select all equal radius cylinders to find other bodies that have the same inside radius as the one we selected. We see that in the status bar it shows 62 faces that have been selected. To get a better picture, let's go ahead and zoom out, or let's click on the Home button in the Orient group. The 62 faces appear to be correct. The next thing I want to do is select the parents of those faces so we can have the bodies selected. Let's click once on Select Parents, and we now see 38 bodies are shown in the status bar. And then let's go to the Layers tab and right-click on Layer 1 and say Assign to Layer. Next, let's deselect Layer 1 by hitting the Escape button or by clicking once in the design space. And let's right-click in the Layer window and say New. We now have Layer 2 created, but before we continue, we'll have to turn off Layer 1 by clicking on the light bulb. We'll box select the remaining bodies. You should have 29 bodies. And then we'll right-click on Layer 2 and say Assign to Layer. Now, let's go ahead and make Layer 0 active again by right-clicking on Layer 0 and saying Make Active. And let's turn on the beams layer and turn off the panels layer. We're now ready to extract our beam elements from our solids. Let's click on the Extract tool in the Beams group. Let's box select around the bodies. And we'll now see that the bodies have been hidden and beam elements have been created. Let's take a look at the structure tree. If we scroll down, we'll see two new folders created. One for beams that basically for each section, for each extracted beam, indicate what profile was extracted. And for the beam profiles, it'll actually identify how many beam profiles that were extracted. Additionally, we can right-click on any one of the extracted profiles and edit them. When we do this, notice it opens up a separate tab that allows us to modify the profile or assign parameters to them, but when we're done, we simply just exit out and the profile updates. Next, let's click on the Connect tool in the Beams group. The Connect tool is going to search for any gaps between the endpoints of the beams. Right now there are no identified gaps, but that's also because it's only searching for a maximum distance of 0.1 millimeters. If we modify this value to 50 and tap the Enter button on our keyboard, we now see that there are 28 gaps. And though we can click the green checkbox to try to fix them all, let's just zoom in and take a look at one example of what a gap would look like. In this example, we don't really have a gap, but what we actually have are endpoints that extend past an intersection. The Connect tool will also search for these examples as well. So if we click on the red dot, we'll see that both of the endpoints have been trimmed back to the vertical beam. Let's zoom out and take a look at one more example. If we move along the beam to the right side, we'll see a much larger gap here. This is a pretty big gap. But what it also has is also a beam that extends beyond the horizontal intersection as well. So we can click on the red dot here and see that two things have actually happened. The endpoint trimmed back to the nearest intersection, as well as the gap was actually closed by bringing the endpoint to the nearest intersection as well. And now that we've seen two examples and how the Connect tool works, we can zoom out or click the Home button to see the remaining model and click the checkbox to have it complete the rest for us. The next step is to check the gaps between the beams and the mid-surfaces. Let's turn the mid-surfaces component on by checking the box in the structure tree. Let's zoom in to the top left corner of the structure, and we can clearly see there are gaps between the mid-surfaces and the beams. To close these gaps, we'll take a look at the Extend tool in the Analysis group. In the Options panel, let's check the box for Extend to Curves, and let's increase the maximum distance to 60 and tap the Enter on our keyboard. We now see that edges are highlighted in red, and if we click on them, they'll extend to the nearest intersecting beam. We can do these for straight beams and edges, as well as curved as well. In this example, we've got a curved edge, and if we click on the red line, we see that that extends to a curved beam. Another example, if we look towards the bottom, are endpoints of beams that can extend to the nearest intersecting surface. And if we click on the red dot here, we see that that is trimmed off. Let's go ahead and click the green check mark to finish the rest. Oftentimes, even though it says it fixed 23 problems, we can see there may still be gaps in other areas. We can reactivate the tool by either unchecking or rechecking the Extend to Curves option, or we can exit out of the Extend tool and go back into it. Here we see we have more options as well to click on edges and extend them to the beams. For the remainder, let's go ahead and hit the green checkbox again. And now we've completed the remaining parts. Let's exit out of the Extend tool, and let's take a look at a validation tool that will help us determine if we've got all the connections we need. Let's click on the Home button to zoom out. Let's click on the Beam Extraction component at the top of the structure tree. And in the Properties panel, for Shared Topology, let's set it to Shared. Next, let's click on the Show Contact button in the Validate group. Here, we see that all of our connections are highlighted in blue or have blue circles. So if we zoom in to the same corner we've been working on, we see that the edge that we extended is blue, as well as the points here are also blue as well. So this makes a great validation tool to ensure you've got all the connections in the correct places. And if we have areas like these where they're curved edges and we had to extend them to the corner, we can do that as well by hitting escape on our keyboard to exit out of the show contact tool. Let's go to the design tab. Let's click on the arced edge here and hit the fill button. Hitting it once simplifies the curve into a line. Hitting it again simplifies the line into a point. And then now we have a sharp point. And if we go back to the Prepare tab and turn Show Contacts on, we now see that we have a single point here as well. In this example, we see three beams intersecting each other. If we rotate the model and look inside the square tube, we see that the beam looks like it intersects first on the outside of the tube and then at the center. Let's go ahead and extract the beam elements by clicking on the Extract tool and box selecting around the model. And then now what we can do is activate the display drop-down for solid beams. Here we're able to see the beams and the bodies at the same time. Here we can clearly see the intersections a lot better. Next, let's activate the Split tool, and we'll see that Spacelane detects the intersections towards the outside. We can go ahead and hit the checkbox, and when we're done, let's change our display settings back to wireframe. Let's hit the Escape button on our keyboard to exit out of the Split tool, and let's use our cursor to hover over the beam, and now we see the beam is split into two sections. What we'll need to do is select the smaller portion of the beam, press and hold the Control button on your keyboard, select the other small portion as well, and in the Properties panel, we'll set the beam rigid to true. This allows us to specify that these are fixed and that these outer beams are not. This concludes the beam extraction tutorial. Thank you for watching.